Welcome, everyone. Good morning, good afternoon, good evening, depending on where you're joining us. I'm Savina Carluccio, and I'm the Executive Director of the International Coalition for Sustainable Infrastructure, or ICSI for short. We are the convener of this webinar series on transforming engineering education, together with our partners, the UN Environment Programme, and we have our colleague, Rowan Palmer, who joined us today, and it will help with support this event, and colleagues also from the Duke University, the Nicholas Institute for Energy, Environment, and Sustainability, also with us on the call, Sarah and Andy. Thanks for joining us today, for helping. Um, I would like to first of all welcome you all, and also encourage you to say hi and introduce yourself in the chat, and say who you are and where you are joining us from today. As Carla has already started doing, if you can, because these sessions are actually quite supposed to be quite, personable, I suppose. If you can, it would really encourage you to have your camera on, even if it's on. We're still doing presentations now. It would be nice to see you all. So please do have your camera on if you can. Would love to see your faces. Thank you, Carla. And yes, so this is, we are now session 4 of this webinar series. We had a quite interesting previous sessions, and it's nice to see that some of you joining us today are actually returning, and it's actually a very nice thing to see, but also something that we want to encourage, because this webinar series is also one of the aims is to form some sort of a micro community of practice around this topic on transforming engineering education that we're obviously all interested in. So today, just first of all, we are recording this session as we did record previous sessions. So hopefully that's okay with you. Oh, hello, Vincent from Uganda. That's great. Getting someone from Africa joining us today. Thank you for joining us. We have a common format for all these webinars. We have 2 presentations. So one more technical and one is more a case study presentation. And I will introduce the 2 speakers shortly. These 2 presentations are followed by a breakout discussion. We'll then come back together into a virtual plenary, sharing. Oh, Liz, hello. Plenary to share key highlights from the discussion, and then we'll bring it to a close. Um, so next slide, please. So the IO stands for Infrastructure Sustainability Learning Initiative. It is a capacity building knowledge transfer model that borrows and adapts from Project ECHO, which is also one of the partners for this session. These sessions are designed to be quite interactive. So even though we have 2 presenters, and obviously that's presentation broadcasting, but we'll try and keep the interaction with you going. I said most of this already, and maybe just to remind you that if you attend most of the sessions, over 70%, we will be able to issue a certificate of participation. Now, I know some of our colleagues joining today might not be native English speakers or prefer to have captions. So there is an opportunity to do so if you wish to. So this is just reminding you how to actually enable your captions. You can go to the bottom bar, click on the more, 3 dots more, and then select caption and select the language that you would like your captions to be in. So let us know if you need any assistance with that. So this is the number 4 of a series of different sessions. Today we're talking about transdisciplinary approaches and system thinking in engineering education. So both of these topics have been mentioned multiple times in all the previous sessions. So I'm really looking forward to hearing a bit more from the presentations and to dive a bit deeper in this too. Because, as I said, something that comes up time and time again, and so I'm kind of curious to see, how people have been tackling implementation or integration of this type of approaches in their engineering curricula already. And I also want to hear about challenges and examples that already exist that we can learn from. So this is all about sharing, but also learning from each other. So we before I take too much of the time, because we really do want to have more time today to have the breakout discussions, I'll just start with our first interaction, which is a Mentimeter. We normally do two Mentimeter questions to just a bit of an icebreaker. And today you can access Menti either on the website and you enter the code, or you can scan the QR code on the slide. And this is really to take the pulse, I suppose, on, we talked about system thinking multiple times. We said that it's needed, that we need to integrate it into education. But how much do you think is it's actually currently being integrated into engineering education? I'm curious to hear your thoughts. Let's just take a pulse. Yes, and I forgot to mention that we would like to get feedback from you, and we will circulate again the feedback form at the end. It's important for us. So, can you rate the degree of integration of system thinking in engineering education between zero, no, from 1 to 5? People are quite evenly split in between minimally integrated and well, can't speak today. I need captions for my for my own speaking. Moderately integrated. So, okay, so definitely something that is has been identified as something definitely something essential to be able to tackle the complex challenges ahead. The wicked problems, I'm sure one of the presenters will talk about wicked problems. But how do we actually improve? So we think it's minimally integrated so far, or moderately, so definitely room for improvement. All right. Okay, so that's good, because that means that this type of discussion is needed on how actually we do it. So I think I can probably then start introducing the first speaker. So we are going to hear from Dr. Tom Dolan, who is currently a freelance interdependent systems research consultant. And that's a great topic to have, as a research topic. I've known Tom for quite a long time, and I know Tom is both really knowledgeable, but also quite passionate about system thinking and system approaches, interdependent systems for sure. So let me just tell you a little bit more about Tom. It's got over a decade, I would say a lot more than that, over a decade of professional experience in environmental policy and water management, focusing on sustainability and resilience in infrastructure system. That's your research experience. You previously worked as a senior research fellow at the UK Collaboratorium for Research and in Infrastructure and Cities, UK CRIC, where you focused on developing systemic principles that steer us towards a resilient, sustainable, and net zero future amidst the climate emergency. So, Tom, I think like you probably are one of the best people I could have really hoped that could be presenting to us today. So, thank you so much for joining us. I know you will be sharing your slides, so maybe you can start doing that. And in the meantime, so Tom will give a presentation. We will hold off questions um, until the end of the second presentation. But if you do have questions in the meantime, please pop them in the chat. So Tom, we can see your screen. Okay, so over to you.
Brilliant. Well, thank you, Sabina. It's very nice to be able to share some thoughts on systems thinking and in education with those gathered today. Um, so my opening comments really are setting the context. So in the context of an increasingly complex, interdependent global and national economy and societies, the vast majority of the research challenges we face, they possess societal and economic, environmental and historical and technical characteristics, and often they're problems emerging from complex systems. They're wicked problems on occasion and not subject to the same tame solutions that we've used to address past challenges, and they require transformative action. So yeah, few if any research challenges are 100% technical in nature. You can't just focus on the technical components in complicated or complex problems. So this makes the ability to adopt a systemic perspective when framing these research challenges and undertaking this research, and I think this is true for projects and planning and policy as well, makes, when designing methodologies or undertaking research activities, communicating research outcomes, reviewing research and critiquing the validity of different approaches to research, it's becoming an essential skill set for a successful research career, I think, to dabble in systems thinking. And likewise, I believe this is probably true for careers in other professional fields. We're all facing the same type of challenges, and I think systems thinking has a lot to offer. So that's my motivation, really, in thinking we should integrate systems thinking more into the engineering education. But I would argue not just engineering education, but all education. And I'd say it's in the researcher's interest to develop these skills early. I think we're still at this stage where the researcher who develops these skills will have a first mover advantage. They position themselves as future leaders with the vision to shape research agendas in their fields or policy in their areas that they specialize in. And I think a systemic mindset, wherever you wind up, wherever you apply it, adds value. So that's my opening comments. My research, Sabina mentioned the projects I've been involved with. So throughout my career, I've applied systems thinking mindset to support analysis of challenges related to the purpose, the performance, the vulnerability, the interdependence, the resilience, sustainability, and the impacts of infrastructure systems. I became a systems thinker by accident. I was being what I thought was logical in an approach to a research problem, and it was declared by my supervisor at the time, well, we have a natural systems thinker. And I was like, but this is just taking a problem and breaking it down and asking awkward questions. But there's more to it than that. But in essence, that's that. So as a consequence of my experiences in research, looking at different challenges, I believe that all research projects can apply a systemic perspective, that doing so benefit the researcher, the research project, the research client, and more broadly benefit society. So adopting system thinking approaches can help to tackle all research challenges more effectively. So this belief has led me to previously host a number of workshops and try to develop some tools to encourage my peers in other fields of research and policy making and consultancy to try to integrate systemic perspectives into their work. So what I'm going to share in the coming slides is just details of 3 of these. But before I do, systems thinking. So systems engineering is an invaluable, rigorous, and well-defined discipline. For me, and this is personal, systems thinking is so much more. Systems thinking is more a mindset than a set of rules. It's about, as Donna Meadows put it, it's about dancing with the system, getting to the beat of the system, really understanding the intricacies of that system and the interdependencies that make that system possible, but also make that system vulnerable at the same time. So it's the ability to step back and look at the big picture, to understand the significance of getting the problem framing right, to be able to identify and analyze those dependencies and interdependencies that are important, and those that make the system vulnerable, and those that don't. So I could go on with a list of so many more things, but that's not why I'm here, because we're all interested in systems thinking, and we've all got our own takes on it. So as I say, I will just share some tools that I've been developing and trialing. Oh, sorry, I missed this bit out. So in my research world, applying systems thinking, I always start by trying to develop a model of the system. So a conceptual model, typically, trying to understand those movements, those flows, those what in outside of the system or the organization or the project is that project dependent on, and then the past, so how it's come to be as it is today. I imagine many of our cities, if we were designing them for purpose, they'd look very different to how they look today. That they've evolved, they're path dependent. We do things how we do them for a good reason at some point in time. Whether it's still a good reason at the current point in time, I don't know. And just to map those interdependencies and to have a real clear take on the purpose of the system. And this will be different for different stakeholders. And to try to align everything with actually a vision of what it is the outcomes that people expect from the system are. So that's try to ground things in that way. So
sorry to interrupt. Could you speak a bit closer to the microphone?
Okay, sorry,
it's
yeah,
a bit
yeah,
hard. Okay.
The mic had drifted away from me there.
All right. Okay. Thank you.
So put together an A to Z of systems thinking, which I can share if people wish, but it's still a work in progress. And the conceptual framework that I mentioned. So, and this is the process I encourage people to go through. You've got your research challenge, or you've got your problem you want to resolve, but it exists within the context of your field or your discipline. So you need to think from there. And your field or discipline exists within a research landscape. And that research landscape exists within a set of enabling systems that's made possible by the infrastructure that supplies the power to your things, by the institutions that fund, by a whole array of things. And there's social structures and processes. So all these layers are nested, and you need to think at this level of abstraction in and out of your problem. Societal rules. So why do we do what we do? And societal goals. What is it that we're trying to achieve? What is it that we believe? What are our values? What government policy is ultimately the research challenge linked to? And then there's the impact of the global society, the tight coupling with the natural environment and flows of things such as carbon or energy or water, and how that really shapes the challenge or the field you're working in. And we've got the historical context, which kind of weaves in and out of all of them. And we've got the future. What do we want the future to look like? So if you take any research problem and you've got it tightly defined, but you need to abstract up and look at all of these levels with a bit of consideration, and that will help you to hone systems perspectives into your research problem. At least this is my assertion, and I believe it's what I've done through my research. So all of these layers have an influence on your research, and hopefully your research has an influence on all of these layers for the problem you're attempting to challenge. And obviously these layers aren't independent of one another. There's some kind of continuous feedback between them. So as a good systems thinker, I can't resist drawing some closed loops with arrows. So I've tried to apply it to net zero greenhouse gas thinking. So I've just come up with some keywords for each layer. Because time is scarce, I'll leave the slides for you to look at. I won't go into all of those. Another key thing that I really, when I think systems thinking, it needs to be integrated not as a subject in its own right, but as integrated into all disciplines. So just the ability to ask awkward questions that other people think have already been answered, and that when often they haven't. Like the clear definition of purpose. Is purpose commonly shared by all stakeholders? Is a very key question, and that can be integrated into any discipline. And the ability to ask good questions is part of the education system, I would have thought. The ability to ask about the origins and the characteristics of the research challenge, and then to define the problem type. Is it a linear, simple problem that can be solved by a linear, simple solution, or is it a complicated or a complex problem? Is it even a wicked problem that is very, very much difficult to resolve unless you can transform the system from which it's emerging. Wow. And then other things like problem framing, and then just asking questions about the wider context of your problem as well is important. And I'll just quickly point you in the direction of a useful resource. Colleagues at UCRIC and the Built Environment Connective have produced this. It's a prospectus, and it's got a list of all the courses they believe to have a systems thinking element to them, currently available in the UK across different levels of education, as I understand it. So I think in the slides I've hopefully got a link. If you click on the slide, it will take you to the website. So I've raced through a bit. Questions are welcome later, and please feel free to contact me to discuss anything I've mentioned or to propose future ideas for collaboration on this topic.
Great. Thank you so much, Tom. Yeah, that's great. Thank you for also keeping to the time. I was worried about the number of slides, but actually we had a lot of animations. And you also mentioned wicked problem twice. So let's see if Susan is going to mention wicked problem some more. You can, huh? I'm just saying. All right, so thank you so much. Actually, before I come to you, Susan, we haven't the other Mentimeter. I forgot that we had an interjection between the two presentations. So if you just bear with me for a couple of minutes while I actually ask this other question. So the first question was about system thinking, integration, and because we also want to talk about transdisciplinary approaches. And this is more of an open question. What are the main barriers to transdisciplinary approaches? I guess in your own area of work, but also in applying it to engineering education as well. So the Mentimeter QR code is there. Yeah, please engage with us. We need maybe colleagues that are kind of, yeah, great. If you can start showing results, and then you just have a think about what you think the main barriers are. For sure, complexities, that one barrier for sure. This is something. Funding, yes, completely. Funding is always a barrier. There is someone in this group that really is, about going about age. It is age. Maybe it's not mental age. Maybe, you know. But resistance to change, maybe. Resistance to do things differently. Unintended consequences. That's an interesting one. We can expand on in the breakout discussion what we mean. I mean, transdisciplinary approaches are probably unproven. Lack of frameworks. Within academia, faculty incentive structure doesn't incentivize. Yes, it's definitely. And then the collaboration, transdisciplinarity entails like a collaboration at a level that is a lot more advanced that what we're used to do. Yeah, what is the job? What are the budgets? Yeah, some more budget. So definitely funding is coming up quite strongly. Yeah, defining the problem. Helps a lot to one person have a foot in more than one discipline. Yes. Great. Okay, so that's good because we get some thoughts and we can and jargon. Yes, that's the theoretical sometimes how some theoretical sometimes these things can sound is a barrier. Also, I feel. So good to have some thoughts and we can discuss further in the breakout discussion. But let me now go to Professor Susan Krumdiek. She is a professor in mechanical engineering, but also chair in energy transition engineering in Heriot Watt University. So Susan, I've collaborated with Susan over the past 12 months on a separate project and really very much enjoyed her take and her thoughts on transition engineering, something that she's actually I suppose, developed as an emerging field. Yeah, we will hear about this in her presentation. She wrote a book about transition engineering. I'm sure she'll share her work, and she's also research director of the UK Ireland Centre for Net Zero. She's worked on building interdisciplinary research groups, programs that integrate research and education in industry, society, and governance needs in understanding and navigating sustainable and renewable energy systems transition. So enough from me, and now over to you, Susan.
All right. Assuming everything's working great, then that's just myself there. And here we go. A couple of links for you. A link to my book, to the Global Association for Transition Engineering, which is a transdisciplinary organization, not only of engineers, but of non-engineers. So we have lawyers and architects and things like that. So true transdisciplinarity, which I've got to say, added about 4 years to the process of getting approved as a charity. Trying to explain how are you going to do that. And then the Island Center for Net Zero, where we're working. The idea there is a remote place called Orkney could be a good test lab for things that we haven't done yet. So I was asked to talk about the Systems Transition Engineering Processes program that Harriet Watt is undertaking. That is, I have a collaborator who's been working with me on the teaching for that, Paolo Carbini. And we have partners, including GATE. We held some workshops at the Transdisciplinary Engineering Conference in London in 2024. And that went a lot better than I thought it was. I had a lot of trepidation about how do you, but of course they were self-selected transdisciplinars. But still, what we did for a workshop was to build a curriculum. Let's say that we were to build a curriculum that taught the things that are needed to deal with the wicked problems of unsustainability. And we've also got a network across the UK working on basically that, building that curriculum and establishing a discipline. The motivator for the discipline is that we've got a place we got to go and we're not exactly sure how you get there. So that must be an engineering job, because engineering built everything we've already got and all that needs changed. So the need for the initiative comes of offering transition engineering as a disciplinary course is that industry, government, consultants all universally express the need for approaches and methods. Not so much the thinking. I think they've probably already done some systems thinking, but the methods for accelerating the net zero transitions. And they're all being asked. All the clients want sustainability. But I think sustainability might be different from working on what's not sustainable. And that's what transition engineering is about. All right, so the objective of our work actually required convergence. That's the transdisciplinary part of this. Convergence is an interesting idea of bringing together what already is, as opposed to sailing off to find new things. So put together what we've got, and if we need new things after that, we can do that. And the deliverables were the teaching materials, courses, case studies for undergraduate, masters, and continuing professional development. So just those little things. And the location is Harriet Watt University in Scotland, but we do have a global online course that is one of the things we've developed. So the first thing out of the blocks was actually, well, the very first thing was actually at University of Canterbury in New Zealand, which was an online micro-credential, because the government had offered some money in the tertiary education block for people who could teach at a postgraduate level the skills that were demonstrated to be needed by industry. And so we went out to industry and they said, we need these sustainability skills. We need to know what to do about this. And so we did an online course, but it was a micro credential. So a 30-point micro credential that included a project at your work. So that went pretty well. And we had people taking it from all over the world. But then when I came to Harriet Watt, we set up an MSc. They love their MSc in the UK. So in the MSc is the transition engineering theme. So we've got 2 courses in there. And the rest in this one, renewable and sustainable energy transition, is renewable energy, economics, commercialization, future energy, whole system change, and an elective and a dissertation. So pretty straightforward, except for these 2. What is the transition engineering? 2 courses worth. And luckily, the last 3 years, the reason that the MSc students are signing up for our course is the transition engineering. So don't have to face blowback from the university. When you try something new, you never know. All right, so the transition engineering course 1 is the approach of transition engineering, principles, tools, methods. And the very first thing is what it always is for engineering, defining the problem. And in the case of transition engineering, let's define the problem as what needs to be changed. So what is unsustainable about the existing system? And that is a change project for the people who already know that system. Then, of course, we're going to need data and analysis and building project objectives and scenarios. Then systems approaches. Now, this I put for engineers, and I'll flash up to you the systems approaches that we use. But I think it's different, the systems approaches for engineers, because I've been trying to resolve the systems thinking with the practical. How would I teach a method and a practical application for that? And I'll quickly show you what that is. Then wicked problems. Again, this legacy of understanding wicked problems, going, oh, that's a wicked problem. Wicked problems are complex. Wicked problems are. Okay, what's the practical approach for dealing with wicked problems? And so through our research, I think we've got something that seems to work every time. And it involves recognizing that wicked problems are polyparadoxes. It's there's at least 3 paradoxes of things that are true but opposite at the same time. And so we do a psychological, emotional parking and unpacking of that and work through it. So it works. So that's good. And it's in my book if you want to know about it. And then we teach the in-time design approach, which is also in the book. Biophysical economics, also in the book, transition finance, and we run through case studies. And then the real world transition engineering lab, we actually run with stakeholders in the community. So we have to do background research, learn about a thing. There's the usual 4 stages of a project. We do a wicked problem investigation with stakeholders, use the data and modeling that is correct, do the in-time design, and out of that comes an actual project or 2 or 3 that could be done. So some concepts for going forward. We present that to the stakeholders and write the reports and see where we go from there. And that's where the Island Center for Net Zero is available to take any things forward that the community wants to see. And for that, we have developed a Transition Lab handbook in which you will find the systems approaches for engineers. All right. Imagine these are layers, underlying layers of the system. One layer of the system is the activities that we need to do. So you can map out the activities, the infrastructures and technologies that you need to do those activities, and the relationship between the activities. So the biggest activity we all do is sleep. So you need the place to do that. And you need to work in order to afford the place to sleep. So you need the transport between the 2, right? So just thinking through that for whatever your project is. So I've put everything we could think of on the plate there for that one. And then there are commonalities throughout this, and let's call them ecosystems. So we have an ecosystem model, which I think works pretty good. And then we have a value system model. So how does money flow? How does value get built? How does value get, what do you have to draw down? So we have a value system model. And then we have a engineering model, a dynamic control system model, because some of this system is built and some of it is in our heads. And so how does that interplay? How does it work? And we can work on both of those, but we probably aren't going to change the directive of the feedback control system, which is survival, right? So how do the behaviors follow on from survival, etc. So those are our models. And then the top challenges I was asked for. for transdisciplinary education. I think transition engineering is transdisciplinary. So do I have to duplicate my effort and go develop a course for mechanical engineering and a course for civil engineering and a course for business and a course for math? Well, you know what? Where we landed to teach this transition engineering course is in a school that is a very interesting mashup. It's got civil engineering, geoscience, petroleum engineering, social science, and energy it's called, but I think that's actually the petroleum. And my school actually has the biology, so it has marine science. So we're transdisciplinary from the start. So even though I'm teaching transition engineering, it's not a engineering thing that only engineers can take. So we can teach engineers and we can teach together everyone else. And so we also have people from design. So what we're doing is, which has been the biggest challenge within a university setting, to get the courses, other courses like an engineering PhD student or master's student to be able to take a course in a different school. Because how does the money flow then? What's going to happen? Yeah. So that's my biggest challenge. And I got to tell you, teaching online. But yeah, we're getting better at it, I guess. We keep trying. Not what I signed on for 30 years ago, I got to say. Love being in front of the class. The other thing with transition engineering is that the emergence of a discipline. Most of us teach into disciplines that are well old. They're very established. What if you are in a space where you're actually part of establishing a new discipline? That I don't know. What's the model for that? So very fun there. Lessons learned. I think that the way to take on transdisciplinary education is to do transdisciplinary research. Teaching and research, it goes together. So if you can find people from other disciplines and build a transdisciplinary research group, then the intellectual stimulation, the connections and everything that you need to feed the teaching will develop. So I've given you the link to Harriet Watt's System Transition Engineering Processes Global Research Institute group. And so that is us learning how to actually work together. And I would say, yeah, it took a year and a half before we sort of got done doing the thing academics do, where you just tell each other what you do and start to see how can we actually work together. So this is not simple to work in this transdisciplinary way, but we'd be happy to share our experience and what we've learned about how this actually might work. The key questions related to transforming engineering education in this case study, I think it's the understanding of the role, right? So many of our engineering fields are so old that we never even ask what's our role in society, right? We're already there. That's already been established. But transdisciplinary engineering, and transition engineering, who wants us? Who's going to pay? What job are we supposed to do? And so I think we've found that in forming a new discipline, in looking at the historical formation of new disciplines. And what's funny is so many of them, chemical engineering, mechanical engineering, electrical engineering, they've actually come out of the failures of people doing those things in an undisciplined way. So you get the discipline when the undisciplined way becomes too costly. Yes. And so there we are. This is a little model that I published a little while ago that just really gives the rationale for how we're going about it. So that's about what I've brought.
Right. Thank you so much, Susan. That's you raised so many interesting points. That I've got some reflections, but I wanted to see whether first or maybe while the people think about questions they want to ask, you can type in the chat, or you can just raise your hand. You can also take the mic. But maybe while people think about questions, I'm curious. One for Susan, and in this case is you talk about convergence, and I think you kind of touched upon. This is something I borrowed from you. I use convergence now quite a bit, and when I because but then in that convergence, how much is new and how much is old? Like when you kind of think about transdisciplinary, it's kind of something that is almost like it's not really the same as individual disciplines. It's kind of by converging, you're creating something new. How much of it is you're learning from what you knew before, and how much of that is new?
Right. Well, that's a good question. The convergence theory, if you want to, the way I think it works, is actually in the same paper as that theory of corrective discipline evolving. And it's that in sustainability. Now, let's remember that's what we're talking about. We're not saying we need to converge together. We need to be transdisciplinary in order to have better Netflix. That wasn't our problem. Right? We're really taking on the big, wicked problems of unsustainability. So, in order to do that, I think those of us who've made our career in this space, we want it, in the 80s, we went into engineering to do sustainability. We were going to fix things, right? And because there's been no discipline, we've all been making up our own stuff, right? We've got lots of people with their own thing. And so it can't be that we need one more new thing in order to figure out how to turn the corner, how to get to where we want to go. And so if you look at that historical model of change, what you see is that when you come together around what's not acceptable, what's causing the losses, what the problems are, then you get much more focused on any new thing is actually about that. But you bring all of the knowledge that you already have, all the ideas you already have. And I think that's a little bit harder than you think it is because we've all been going alone for so long that to come together and to just trust that other people are going to recognize the contribution we're bringing, that we're going to figure out how to slot it all together. That's sort of how we've gotten to transition engineering so far, is by bringing together people around the world, most of them professionals, not academics. Here's what's worked. Here's what's worked. Here's what didn't work. Why didn't this work? Right. And
Right.
going that way. So
Right. Thank you, Susan. I do have another question for you, but in the chat. But before that, I wanted to ask something to you, Tom, and based on your experience trying to get people to practice, say, system thinking. And I picked up from you because you obviously took it more like research. What the research problem, and apply system thinking to research. And you, Susan, talk about this. You know, you kind of need to apply it to research to be able to also apply it to education. I guess Tom is how can you actually encourage? I'm thinking about the education side now. Like how can you encourage students, I guess, to do that sort of have that to think about interdependencies and system connection. Is this how can you actually encourage them? Have you got any thoughts on this? How,
Yeah, I think systems thinking is something that's taught out of us as we go through as we age and as we go through the school system, because the curriculum is so divided into disciplines, subjects, that I think at a certain stage we stop making those connections. Because I think to be a systems thinker is quite, the willingness to make connections, the creativity to make connections, and to not accept something at face value, which I think is a skill set I see in my children, and greatly diminished in adults. So I think perhaps if we could lessen the emphasis on topics being discrete and separate, and really emphasize connections in everything we learn about, then systems thinking, kind of as a discipline or as a way of looking at the world, will follow. But as it
Mhm.
is, we box things off and we disregard the interdependencies as not the thing we're learning about.
Right, right. So it's, and this is maybe connected to something. I mean, you will have seen many times that kind of T-shape professional that we're trying to create through engineering education, where you kind of got that kind of deep expertise that assumes that you're in a vertical, almost like, right, you need to go deep into, say, one discipline, but then how do you balance it with, actually, no, you need to think broad, right? What do you think about this?
I mean, that's the real challenge: how to get the specialists who have the systems thinking skills. And yeah, I think it my first answer, and also integrated into the subjects themselves at university level, and all research problems need to emphasize that in the framing, in the setting up of the problem, these things have been considered or should be considered. The layers I mentioned in the diagram. So it's just to normalize a whole bunch of processes around really emphasizing the interdependence with the external world.
Right. Yes, T-discipline, breadth and depth. Yes, that's something that comes up, and every time someone mentions it to me, I think it's both needed, but kind of like, how do you find that balance, right? As you saying, Tom. Yeah, you do create specialists. We do need specialists, but we also need system thinkers, right? And can you be the same person? You should, but anyway, so there's a couple more questions I wanted to ask in the chat. So one is, actually, Susan, you've been answering questions, so super efficient. But let me see, one question hasn't been answered yet from Christy. How do you suggest incorporating system thinking across the traditional project delivery life cycle? Does the current contracting approach, scope, schedule, budget, prevents innovations for system thinking? Maybe while you have your microphone, Tom, and maybe just come to Susan, to you as well.
Yeah, I think I've done some work on looking at assessing what infrastructure we need, because the National Infrastructure Commission in the UK have a process for looking at what infrastructure we need over the 10 to 30 years. And for me, that's very constrained by what we've built is getting old. We need more of it, or the population's growing. We need more of this solution. And we frame problems very much in terms of the sector or the technology or the current solution to that problem, rather than in terms of the outcomes we want to be able to achieve. So I think I've lost what the question was, but I think there's a massive element of getting that framing right and thinking about what it is that we want the outcomes to be, not how do we slightly modify what we're doing. It's what do we want the outcomes to be, and work backwards from there.
Thank you, Tom. And Susan, yeah.
Well, you know what we've ended up doing, because we're doing these live labs, and because we've been doing real projects, is that we've actually developed a workflow. So, in engineering project management, there's a workflow. And if you're gonna expect to get paid for the work, then we're going to do this much work, you're going to get this deliverable, you've got to have a workflow. And what we've found is that the appropriate systems thinking goes into each piece of the work. So it's just a continuous way of working, and you have the tools there, and the tools have a dual job. They have letting the engineers make sure that and the participants make sure that they've got all the information, that they can get mental images of things, that they, get the systems view, but also communicating with other stakeholders and funders and etc. So if you think of the systems thinking as a must for communicating, then the one thing we don't find ourselves doing very much is the stock and flow diagrams. Those have a very specific purpose, but for communicating, it gets lost. Yeah.
Right. Yeah, which is almost bring it back to, how much do you need the jargon, right? Much do you need to be conversant with the jargon, the principle, the kind of the key concepts before you can actually practice, say, system thinking? That's kind of something else, right? And maybe there is a comment here from Carla, um, who's coming from a different context where, like she's saying, survival and kind of basic needs is kind of coming first and before, sustainability and other topics are seen perhaps, less of a priority because there's more pressing needs. So that's kind of yeah. And then she's also say these subjects as a mass in curriculum macro credentials. Yeah, what about macro credentials? What do you think about this as a mean to kind of
Um,
upskill people?
okay, if I'm right that this transition engineering is transdisciplinary, well, we find it always is, so it probably is. And if I'm right that it's a corrective discipline, that it's one of those things that when the way we were doing it is causing too much unintended consequence, then we find a disciplined way to do it. Then I think it follows from that. So if I'm right about that, then think about safety engineering, which was probably the original of the corrective disciplines. And in safety engineering, I'm pretty sure they're systems thinkers, right? I mean, you
Hmm.
got to be thinking about the people, the context, and all the different materials and what's going on. I think they're systems thinkers. And I think security systems engineers are also systems thinkers. And I think so. I think to a large degree, maybe if you get down into, people who just design water bottles or something, maybe that's not very much systems thinking, but we have it a lot in these corrective disciplines. So don't overthink it. Make sure that it's part of the good education. And that's where the micro credential is going to be key because, like safety engineering, it's a full participation job, right? You might not be the world's expert on transition engineering in food processing, but there is one. And what they are learning, it filters or it disseminates, and it changes and it adds to how everything works. So keep that safety model in your head. Think about that there's only 12 um, accredited postgraduate fire safety engineering programs, and think about how many lives are saved every year around the world because of what they do. And that so much of that has to do with the fire drill that we do.
Mm.
So
Okay.
this sort of participatory enabling, and coming up with the fire detection and the sprinklers. So yeah, whole
Great.
system change. That's what I'll call it, just as a shorthand.
Thank you. Great. So I think we can probably wrap up here the Q&A. I know, Tom, you need to go shortly, so I just want to thank you and Susan. I mean, please, Susan, stay if you can, longer until to just get a little bit more wisdom and inputs in the breakouts. But thank you, Tom. So if you need to leave, please do. Thank you so much for participating, and yeah, just
Thank
please
you.
join us in the future sessions.
Thank you.
All right, thank you. Great. So, see, we're now breaking out into two groups, and we are going to discuss more of the participants' thoughts on what you've heard, but also your own, inputs and insights on the topic of today. So, these are the questions that we will discuss in the two groups. How is system thinking currently being integrated in engineering curriculum? We also want to hear from people, obviously, in the audience and your own experience and something that you know, and sharing examples of institutions or courses that you think are being successfully implementing transdisciplinary approaches or methods in their education. And then we also want to reflect on what sort of resources or support might be required by the educators, so engineering schools What do they actually need so that they're able to integrate system thinking and transdisciplinary methodologies or approaches in their education and curricula. So we're breaking now into two groups. So you'll be assigned to each one of them, and we will be back in about 20 minutes from now. Great. So thank you all again for coming back. We now have just a few minutes to recap on the key points from discussions. So just handing it over to Regina in my group, who will be reporting out on key topics.
We were group 2, but if it's fine for
sorry.
group 1, okay, it's okay, doesn't matter. So we had a very, very good discussion, and I'm just going to summarize the points that I found it the most interesting and also easy to capture and easy to understand. So in the beginning, we were talking about what's missing in education, and one of our participants noted that probably real world examples and working together with different disciplines and working on at least 7-8 systems to make sure that the wicked problems are addressed accordingly. We also talked about the possible lack of quantifying societal impact of the solutions, of the transdisciplinary solutions that these groups are possibly designing and planning. But after that, we were mentioning that such impacts might not be able to quantified and might not even need to be quantified, such as designing a good city. It's something that some aspects might not need to be translated into numbers, such as the livability of a neighborhood or walkability of a neighborhood. Some of these aspects might need to be turned into numbers, but others not necessarily. So it was a very, very broad discussion. We talked about micro credentials. So what's the value of micro credentials, such as doing a short course in transition engineering or different courses? We had different views on that. We also talked about successful courses that include transdisciplinary approaches, and some participants noted that summer schools and short courses offering micro-credentials are the successful examples here. Also, we had a participant from El Salvador talking about how in that context these issues are raised and addressed, and talking about the one-sidedness of engineering education, focusing on numbers and mathematics, and the need for students to understand that engineering is actually designing the future, and their work can be also creative. So just not to be too long, these were my thoughts.
Thank you very much, Regina. And over to the other group, who's quickly reporting out.
I will try as quick as I can. So for the first question, we spoke quite a bit about challenge-based learning as an approach to frame a challenge in a system and then narrow down the scope into a project. So that caters to the transdisciplinary research. You start from a challenge and you work from there. And this approach, when it's used and has multiple stakeholders coming together, can provide solutions from different perspectives. We also spoke about how a reductionist mindset can be both a challenge and a strength in engineering, and how sometimes the holism that comes with systems thinking is missing. So this kind of reductionist versus systems thinking mindset. Some participants pointed out that systems thinking is being integrated as an explicit topic, so lectures and workshops specifically on systems thinking and how to approach it. There were some examples from Duke shared of institutions and courses that have successfully implemented these approaches. So I don't know if Duke colleagues want to share those links in the chat as well. And then in terms of resources and support, of course, Funding, time was a big one that we spoke about, the lack of time for teachers to actually focus on education versus research. A lack of academic credit is a problem for people working on these issues. And we spoke about the need, the clear need from industry for systems thinking mindset. And I think I will stop there, given that I'm 1 minute over already. So
All right.
thank you.
Thank you, Gemma. Thank you again, everyone. So we're closing today's session. Next time, on the 10th of November, we will have it's a different format. We will have a panel discussion about this topic of transforming engineering education, and it will be concurrently with COP, the climate change conference. So we will have speakers, and this will be advertised. So this is not going to be the same format as this session, and the normal format will resume. So this is the COP session, as I said, transforming engineering education for a just, sustainable, and resilient future. We will have speakers speaking to this topic. And then the next topic that we will tackle in the IOL webinar is going to be charting future career paths. So it's just how do we bridge the, I suppose, gap between what the engineering education is producing in terms of professional and what is the market demand for what kind of professionals and skills and competencies that are desirable in the job market, and kind of discuss that specific industry academia connection, whether it's there and what is missing. Great. So thank you so much for staying with us 3 minutes over time. We very much appreciate your participation and insights, and we will see you all next time. Thank you, Susan, so much
Sure.
for your input and presentation today.